Hi guys, so today we're working on the quotient rule. So this is what we use when we need to differentiate a function that has one function divided by another. And you need to learn this rule. So say it over and over to yourself or write it down 100 times, whatever it is you need to memorize this. Because if you don't know this, you're going to find it very difficult to differentiate a function like this. So we call the function on the top, the numerator, u, and the denominator v. So what that means is that if we differentiate y, then the derivative is vu dash minus uv dash over v squared. Okay, so when you're setting this out, what you need to do is first make sure you've got your u and your v, right? And so then if we say let u equal 5x minus 2, then u dash, and you work out what that derivative is. So for ours it's 5, it's pretty simple. And v is going to be the denominator, so 2x plus 5. So then v dash is just 2. And then you substitute, you use v's u dash and v dash up into that formula. So we're going to have the derivative of y is equal to v, so that's 2x plus 5 times u dash, so that's times 5, minus, then it's u, so 5x minus 2, times the derivative of v, so that's times 2, and that whole thing is going to be over v squared. So make sure you're using your brackets properly too, okay? 2x plus 5, and that's all squared. Now, because we've got two sets of brackets and they've both got x's in them, we're going to have things that we can, like terms, we can collect together or cancel out, so you would be expected to tidy this up. Alright, so expand out your brackets. On your numerator, you are going to get 10x plus 25 minus 10x and plus 4. Alright, and your denominator, you can expand it, but you're not expected to because nothing's going to simplify or cancel. So I would leave it factorized. And then looking at that numerator, we've got our 10x minus 10x. So we're going to be left with 29 all over 2x plus 5 all squared. So that's how you differentiate a quotient function. So have a go, pause the recording, see what you can do, and then come back to it, and I'll show you how to do this one. Alright, so we are going to let u is the numerator, sorry, so it's x cubed minus 7. So then when we differentiate that, we're going to get 3x squared. Make sure you're getting these derivatives right, because if you screw them up, nothing is going to mean anything. So v is your denominator, so 3x squared plus 4. So then when we differentiate that, we end up with 6x. Alright, so that's always your first step when you've got a quotient. Then you start differentiating. Substitute into your formula. So remembering back, we're going to flip back. Your formula is vu dash. It's always the denominator first, yeah? vu dash. So vu dash, so we're going to get 3x squared plus 4 times u dash is 3x squared. And then it's going to be minus, so that was vu dash. Now we're going to do uv dash, so they switch, yeah? X cubed minus 7, and that's times 6x. And then your denominator is always going to be v squared, so it's 3x squared plus 4 all squared. So make sure you show those steps really clearly. Don't try and simplify before you've done that. Okay? It's when we start trying to skip steps or combine steps that we start making silly little mistakes. Take your time. You've got the time to do it. Do it properly. So now we're going to start expanding out these brackets because we're going to end up with more than one term that has x to the power of 4. So we're going to be able to collect some like terms. So expanding out the first set of brackets, we end up with 9x to the power of 4 plus 12x squared. and then we're going to have minus, so the 6x times x cubed, so minus 6x to the power of 4, and then we're going to have plus 42x. Again, I wouldn't be expanding out the denominator. There's some instances where it might work, but when it gets really complicated like this, you're better off just leaving it factorized. And then we're just going to simplify our like terms. So we've left with 3x to the power of 4 plus 12x squared plus 42x. And that is all over 3x squared plus 4 all squared. Now you can factorize the top of that if you wanted to make things nice and neat. We've got a common factor of 3x, which would be outside of x cubed plus 4x plus, that's going to be 14. We can't cancel any of our factors out here, but that's nice and neat. That's the derivative of x cubed minus 7 all over 3x squared plus 4. Alright, again, pause the recording, have a go, and then come back and check your answer. Okay? So we are going to let u equal to 7x minus 1 all cubed. Now this is where things start to get, they're a little bit more complicated. You can see that we've got a quotient rule, but then within the quotient rule we're going to have a chain rule. And it can get a bit overwhelming, but just remember to do each thing one step at a time and you'll be fine. Like, the rules don't change, you just do one and then do the next, and as long as you do all the steps properly, you'll be fine. So if u is equal to 7x minus 1 all cubed, then u dash is going to be equal to 3 outside of 7x minus 1 all squared times 7, which, when I tidy it up, is 21 outside of 7x minus 1 all squared. Okay, so we've got our chain rule within our quotient rule. Now looking at v, so if I want to differentiate v, I get 6x minus 4, that's nice and simple. And then we substitute in. So y dash equals v, 3x squared minus 4x plus 2 times u dash, so that's times u dash, so that's times 21 outside of 7x minus 1 all squared, and that's minus u, so 7x minus 1 all cubed times v dash, so 6x minus 4. Alright, then that's all over, oops, sorry guys, it gets a bit complicated. So then that's all over 3x squared minus 4x plus 2 all squared. Now this can get really ugly, as you can see, but so a few tips. If you have a look at this, you've got this factor of 7x minus 1 in both. Now if you start trying to expand all this out, you've got squares, you've got cubics, and you get confused and you make mistakes. To be honest, factorized answers are worth much more to us, because when things are factorized, we can work out zeros, which is very important later on when we're doing calculus. Knowing when this is equal to 0 is an extremely important thing to be able to do. So don't expand, leave them factorized, take out your common factors, and let's see what we get. So our common factor for these two terms is going to be 7x minus 1. Now I can take out 7x minus 1 all squared because I have that much in both. And then, now you can see I've changed the bracket. I've done that because I'm going to get brackets inside of brackets, and it can get very confusing knowing which bracket goes where. So I do a different kind of bracket for the outside and then the regular kind of bracket on the inside. So if I take out 7x minus 1 all squared from the first term, I'm left with 21 outside of 3x squared minus 4x plus 2. And then we've got minus, and now looking at the second term, we're left with 7x minus 1, 6x minus 4. So then we can close that big bracket. And again, that's all going to be over. Now the bottom hasn't changed. It doesn't generally. 3x squared minus 4x plus 2 all squared. Alright. So again, looking at the top, now I am going to get a couple of x squareds left and right. So I can expand these ones out. It is going to achieve something if I do that here. So keeping our 7x minus 1 all squared and then expanding out the brackets inside the square brackets, we've got 63x squared minus 84x plus 42 minus, now 7x times 6x is going to be 42x squared. Let's have a look at what we've got. We've got 7x times 4, so we've got 28x, and then we've got minus 6x, so we're at, now let's have a look at what we've got. We've got 7x times 4, so that's minus 28x, and then we've got minus another 6x, so we're at negative 34x, but then there's a negative in front of that, so we're going to have plus 34x, and things like that are things to focus on. They're a point of weakness. People get the negatives wrong, they expand them out wrong. Double check after you've expanded that you've done it right. Okay, the minus 1 times minus 4 would be 4, but then we've got a negative, so it's minus 4. And again, keeping our denominator, 3x squared minus 4x plus 2 all squared. So then, if we tidy up what's inside those square brackets, we get 63 minus 42, so I've got 21x squared. I've got minus 84, but plus 34x, so we end up at minus 50x. And then plus 42, but minus 4, so we're at minus 38. And then that's all over the denominator, still hasn't changed. 3x squared minus 4x plus 2. So you're welcome to stop there, guys. You've expanded and tidied it up. You can see there's some pretty intense algebra going on in some of these differentials, but as long as you take the things one step at a time, you'll be okay. Just do focus on things like expanding out your quadratics properly, making sure you've got your negatives in the right spot, and working through one step, not trying to combine too many together, because that's when we start to make mistakes. Alright, do as much of this exercise as you need to. Good luck, and I'll see you in class.